Hello my friends, welcome to my electronic channel, this is Calibration. Today, in this video, we will do electronic adjustment of this Hitachi D-E7 cassette deck. I already printed out the overall super bright sheet of paper with barely visible text, because this seems to be a document which was with very low contrast, but anyway, still readable. And we're gonna go through the steps here in order to adjust this cassette deck. Not every step will be performed. For example, I don't have a special torque measuring, a doohickey and head calibration, level, penetration and stuff doohickey, which is obviously a dedicated tools which I don't have. Well, I have calibration tape, azimut tape, level tape, speed tape and things like that, multimeter and oscilloscope, which we're going to be using to check some parameters here. So let's just follow the service manual. Okay, so in service manual we have to set the control and switches in specific positions. So let me probably move it like that. Somewhat like this. Hope it's not gonna fall down. Alright, it says recording level adjustment to max. This is recording level adjustment goes to max. Output level adjustment to max. Output level adjustment to max. Dolby off. Dolby off. It is off. Okay. Then tape selector goes to, let's start from normal. MPX switch off. Monitor switch tape. Alright. And then tape we will pick depending on what we're gonna do. Next one, tape speed adjustment. So next step would be to adjust our tape speed, which says we have to use 3000 Hz tape and make it plus 30 or minus 10 Hz. Alright, and we're gonna be using for that a screwdriver and this potentiometer. Let me get speed calibration tape. Okay, I have prepared my tools. Here is the multimeter, here are the calibration tapes. These are kind of low-end calibration tapes I'm gonna be using at this moment. Let's power this guy up. Okay, and use our let's speed. This speed is 3150. Are we going to be treated it is the same way as it? I don't know what it's catching here. Anyways, and let's play. Okay, so it is playing. We'll be using headphone output right here in front, and we'll be using 635mm headphone jack with multimeter connected just like that. And let's go to AC and Hertz. We have a little bit faster speed than is necessary. Then I have my ceramic screwdriver, which I try to use as much as possible while poking inside the cassette deck, just to make sure I'm not gonna mess it up. And here in the motor on the back there is a little adjustment pod which we gonna use to adjust our speed to 3150. I think we are good. 3150, almost here. Okay, we're gonna stop here. Eject. This is our speed. So here, okay, what's next? Azimut adjustment of the recording and playback head. I think it's time to adjust azimut using the proper calibration cassette. So this time we're going to be using ANT calibration cassette with azimut here. You know, many people would recognize this thing. Let's power it up our cassette deck again. and insert this guy. Okay, we're gonna use oscilloscope and XY mode, which is already set up for that. Okay, let me use this proppy thing and prop the cassette deck up. Okay. Let's go. Okay, well, looks like our Azimut is actually not too bad, if I'm not mistaken. Look at this. It's pretty much 45, like, I mean, there's nothing else to do here. Okay, let's do stop. So at this point, we probably need to move up to next step. Let me just rewind to make sure it's not crazy. I mean, I think this is fairly good Azimut, right? I think it's pretty good. Oh, good. Okay. If Azimut is fine, let's move up to the level, playback level. Ah, look at this, it's barely managing. So yeah, we have to work with this idler. So next step for us, which is barely visible here, is adjustment of reproduction gain. It's essentially playback level. So these are two potentiometers, RT11L and R. So for this, we're going to be using our oscilloscope in regular mode. All right. So this is regular mode. Regular means not XY, but YT mode, like the Y is time base. Okay, let's just play back, because from the very beginning, this cassette tape has 400 Hz, 0 dB at essentially NC Dolby level. And let's see. So this is our level. Let's do measure. We have 400 Hz, 516 millivolt RMS, both channel pretty much, and 520. So we have to reduce it slightly. So we have measurements. Okay, use a ceramic screwdriver and just start reducing. Oh, increasing the wrong channel. Okay, let's drop this channel. Alright, so a yellow is actually a right channel and the blue is a left channel. Let's make it the same level. I'm doing 520 millivolt, I said. And let's do this one. Okay, so our left channel. Okay, this is our right channel, right? We're increasing it. Now we're gonna decrease it. We're gonna switch measurement from one channel to another, which I do not remember how to do so. Let's turn off one channel. Measure. Now it's gonna be blue. 500 for 80. 520. And what we see here in the front, I'll show you. So this is how level meter look like now, and it's actually appropriate. It's 520 and between 0 and 1 is barely blinking. Essentially it means it's a little bit higher, but still pretty good. And recording level of 10 kilohertz signal is minus 12 dB, which is pretty, I would say, close. It's slightly higher than plus 10 because you see it's blinking a little bit up. I think it's pretty good. Okay, so next step would be adjustment of the meter. So we adjusted the reproduce or playback gain. Now let's adjust the meter. So for that we need to connect low frequency oscillator to line in. So over here is my low frequency oscillator. Here's the photo. This is Hewlett-Packard analog function generator 3312 D-E7 very old thing, but it works. Okay, so here's, you can even see some frequencies already. I will adjust it later. 400 Hertz. Okay, set the source, switch to source position. Yes, it is in source position right now, hence you see the signal here, otherwise you won't see anything. Okay, adjust the meter using the attenuator so that output voltage appears at line out is 500 millivolt minus 0.5 dB, which is 490 0.49 volt RMS. So let's just adjust it using the attenuator right here on the function gen. 490 millivolt. I think 488 is pretty good. I know why it's jumping right here. I don't like it personally. Is it unstable for some reason? That's weird. Have to check that, why it's so jumpy. This is better, I think. Okay. It's jumpy. Maybe my frequency generator is old. I guess it's super old. Okay, adjust RTL 12102L. Okay, what here is the meter adjustment. So that dB point of the meter, so that 0 dB point of the meter corresponds to a transient point from off to, it is actually in. It's in. Look, I don't have to do anything. It's already set. Look, here's the video. I think this is what they mean. It's actually transient. So it's a slightly less than 0 dB level. I think we're good here. So our next step would be to find this erase head connector, which is going to be here, and here we are. It actually says erase head. So what's missing here, that you have to put your thing, like in this manuals, it says read, put it to metal, but it doesn't say it has to be in recording mode. So we have to put the thing into recording mode. Okay, now it is recording. Now let's try to measure. Let's try first 1x, and we're measuring 29 volt AC obviously, and let's switch to the frequency. And our frequency 82 kilohertz. Okay, we need more than that. Okay, we need 85. Let me double check later with the oscilloscope. Oh, let's do 85, 83, 84, 85. Let me double check with the oscilloscope. So yeah, so the thing is, you have to measure between this and that, not between this and the ground. Okay, that's the most important, because ground here is just a shield. So in next section, we are going to do coarse adjustment of recording level. So we have to apply 1.2 kHz signal in the range of 520 millivolts minus 10 dB, which is 1.64 volt RMS, which I already set here. But now we have to adjust the frequency to 1.2 kilohertz. Looks like this potentiometer here at the signal gen need to be cleaned, because okay, roughly. Okay, so this signal will be recorded on, it says, alright, the source. That was source, voltmeter, then set the monitor switch to the tape position and adjust to that output voltage is this. Okay, so they kind of omitted here that you have to use the metal cassette. Why? Because in the previous section you were recording on metal cassette using Dolby, so, and I skipped the whole thing. Not gonna adjust any Dolby level here. So here's the metal cassette, and we started recording. Metal position here is set on the cassette deck. Let's switch to... Okay, now it's alright. So yeah, we have to double check this switch because it might have an issue. Okay, so now we have very nice show of the signal here, and on output we have... It's roughly where it's supposed to be. Alright guys, I think I found an issue, so take a look at this. So please make a note, 128 millivolt RMS. Stop. 1, 2, 3, 4, 5. $150 millivolt RMS. Let's stop it for a bit longer. Let's try to rewind. $200 RMS. Yeah, I think we have a little bit of a problem, because what's gonna happen now, if you leave it going for a while, this level would drop. You see, it's already slightly dropping. So if you keep it recording, it's gonna be slow, lower, 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 and lower. And I have a little suspicion here what's going on. Okay, so now when we are more or less rectified the problem with the bias oscillator by using beefier transistor Toshiba TTC004 instead of whatever was here before, and whacking pretty solid heatsink on it, it's more or less stable. And I still have this little potentiometer right here, which I'm gonna tweak the metal cassette bias level. Alright, so what you have to do is to stick the metal cassette, we set so coarse adjustment, connect low frequency oscillator to line in and apply signal 1.2 kilohertz, and then make the level at 520 millivolt minus 10 dB, which is 164 VRMS, millivolt RMS. Alright, then set the monitor switch to tape position and adjust RT201. This is our bias adjustment, but we're not gonna touch that. Where are 201? So those two, that on output, it's gonna be the same voltage. Let's do that. Gonna use our ceramic screwdriver for this. Alright, let's do it. So let's put it in our record mode. And do the source. And what do we have? We have more than needed. So we have to dial it down. It has to be 164 or 168 actually was on input. And another one. But there's no easy way of switching the measurements. Yeah, perfect. From one channel to another, at least I didn't figure out how to do so. Okay, so this is our signal, this is our measurements. Perfect, 168 volt. This is done. So I don't think I need to actually tweak the bias unless I want to crank it up to, well, it's gonna be working fine. All right, so I think we've done that. I wanted to crank it up to higher frequency and higher amplitude, but that we're gonna check in the next steps. Alright guys, so let's continue to step 7. And step 7 is a fine adjustment of bias current and adjustment of recording level. So for that you would need type 1, first step, type 1, cassette. This is going to be Sony HF. Then we're going to use 1.2 kilohertz at minus 20 dB. I'm not going to use minus 20 dB, I'm going to use minus 20 dB, which is 50 millivolt RMS, or 52. So I have already set, right it here, it's 50. That's a source signal, 50 millivolt, and we will continue with 1.2 kilohertz. So let's do it. Okay, let's switch to tape, and our tape is not spot on, almost there. So what you have to tweak, 501. Where's the 501? So 501 are these guys. So this is bias level. So let's see what we can tweak. Will it change something? No, it's a different channel. Let's change this one. It's dropping. Okay, opposite direction. Yeah, it looks like this is 48 is the best I can do. Okay, let's switch measurements to different channel. Well, I want them to be identical, the same level, those two channels. Okay, more or less. Okay, now let's try 12 kilohertz, the same. Okay, we have 12 kilohertz. Yeah, looks like bias is substantially higher. So what we have to do here, we have to, I don't know what to do. It's too high. Yep, this is way too high, so we have to reduce bias on this. Okay, it's dropping, so 0.6. Oh, it's seriously dropping. Much lower. Wow, I don't know where to find this medium. $46, 36. So I try to find like something like that, and then let's do 1.2 kilohertz. Sorry, 12 kilohertz again. $82 millivolt. Yeah, this is like, it's too high. Wow, it's too high. It's recording like. Okay, well, I don't know what. Okay, so let's see. Let's make a note here. 12 kilohertz is too high. 12 too high. Alright, so our next step is to use the same normal cassette, 1.2 kilohertz, but this time 250 millivolt minus 10 dB, which is 164 RMS on oscilloscope. So we have 168. Alright, so let's just start recording. And that's what we have. So this time we have to tweak recording gain slightly. Okay. We align both channels together. Now we use normal tape and double check. Pretty much we repeat step number 2, but instead of adjustment we do check. So now just do the same, 1.2 kilohertz minus 23 dB. This seems to be alright. We can just bump it up a little bit. Okay. Then we do 12 kilohertz. Well, this is not alright, but nothing I can do. That's a note here. Then we use chrome tape. And for chrome tape we have this beautiful Maxell XL2, my favorite design, one of my favorite designs. Let's switch to Chrome. Let's do recording. Okay, I think that's pretty much there. 12 kilohertz. Let's do 1.2 kilohertz. It's a bit lower than I needed to, I think. Oh no, it's me, my bad. Okay, perfect. That's actually doing well. Let's stop it. And let's do 12 kilohertz for the Sony Metal SR. What that's really supposed to mean. Okay, that's better. Oh wow, it looks like shit when it is at Chrome level and stabilizes. Actually, this is still within the. That's actually how it's supposed to be. That's very good. 1.2 kilohertz. Oops. And 12 kilohertz. Very good. Okay, I think this step is complete. I think it's actually plus minus 3 dB, but that was actually way better than plus minus 3 dB. It was pretty much spot on. Alright, so let's move to the next step, which is we need to find the sheet for that. Well, turned out to be there is no step 8. Well, step 8 is there, but it's mostly mechanical adjustments, which I cannot do because I do not have appropriate tools for the chassis section. It's like pinch roll compressive force, stirrup driving force, take up torque, FF torque, rev torque, supply back test. Like, I cannot test all this, so just don't have gear for that. So this is step 8 is done. Over here there is just an explanation of what we done here essentially. Step-by-step explanation. I think we're done here. I think the final step of recording is very good. And bias, as you see, it's holding off more or less at the same level, so its temperature is not drifting. And heatsink here, which is the major issue, was during my troubleshooting video, is I think it's good. Okay, I think we finally tuned up this wonderful why I say Nakamichi? Hitachi D-E7 cassette deck. Now, what I have to do is very important step, is actually capture frequency response curves as it is in this calibrated state, and I'm gonna share with you. Okay. Oh, and also I have to. The very final step is actually solder put the proper resistor for this. Measure this resistance and solder the resistor. And last time we measured this, it was 11 kilo ohm. So I need to put two resistors like 10 plus 1 kilo ohm or something to this extent. All right, guys, let me run frequency sweeps. That's gonna take some time because I would like to do this for metal. At least 4 sweeps, normal 4 sweeps, and I'm gonna be doing minus 20 dB, minus 10 dB, 0, and plus 3. And the same do for all 3 types of formulations. That's gonna take some time. So wish me luck, and let me finish that.
Here we are. These are results of my frequency sweeps. First one is the Sony HF90 Type 1. So across all my frequency sweeps, recorded levels are minus 20, minus 10, minus 5, 0, and plus 5 dB. Also, the dashed line represents total harmonic distortions plus noise measurements. And as we see, the minus 20 and minus 10 show the lowest level of THD plus N. And plus 5 dB, of course, is so much higher distortions. Next one is Maxell XL2 Type 2. Now we see that I made a mistake here, and looks like minus 20 dB was not recorded at correct level. It's more look like minus 15 dB. But nevertheless, still it shows a little bit better performance than Sony HF, especially in THDN department. Next one is Sony Metal SR. Looking good, especially at 0 and plus 5 dB and that frequency response, and less distortion as well. In conclusion, I think we have fixed the tape deck and recording is looking quite good. Well guys, I think I'm gonna wrap up this video right now. Please don't forget to subscribe, like the video, comment, I'll be happy to hear from you. Please see my other videos about cassette decks. Stay safe, stay tuned, and ciao.